Have you ever found yourself daydreaming about what it would be like to travel through time? Maybe you've wondered what it would feel like to step into the distant past, or leap forward into a future filled with amazing technology and discoveries. The idea of time travel is something that has fascinated people for generations, sparking our curiosity and imagination. It's a wish that many of us share, no matter our age or where we come from. Imagine being able to witness the building of the pyramids, or see the first humans walk on the moon. What if you could meet your great-great-grandparents, or see what life will be like hundreds of years from now? Time travel would let us experience history firsthand and maybe even get a glimpse of the future that awaits us. The possibilities are endless. Would you visit the age of dinosaurs or explore a world where robots and humans live side by side? Time travel isn't just a dream, it's a huge part of our stories too. From classic movies to best-selling books, people love to imagine what it would be like to jump through time. We see heroes racing against the clock, inventors building wild machines, and ordinary people caught up in extraordinary adventures. These stories let us explore what-if questions and inspire us to think about our own place in the universe. But is time travel really possible, or is it just a fantasy? Scientists and thinkers have debated this question for years. Some theories in physics suggest that time might be more flexible than we think, while others say it's impossible to move backward or forward in time. The truth is, we're still trying to figure it out. If we could control time, what would that mean for us? Would we use it to fix our mistakes or to learn from them? Could we change the course of history? Or would we discover that some things are meant to happen no matter what? The idea of controlling time brings up all sorts of exciting and sometimes tricky questions about responsibility, choices, and the way our actions shape the world. Thinking about time travel makes us ask big questions. What is time really? Is it a straight line, or can it twist and turn? Does it move the same for everyone, or can it be stretched and bent? These questions don't just belong in science fiction. They're at the heart of some of the most important scientific discoveries of our time. Can we really change the past, or is it set in stone? If we could see the future, would we want to? Would knowing what's coming help us, or would it take away the excitement of discovery? These are questions that challenge our understanding of life and make us think about what it means to be human. Even though we haven't built a real time machine yet, just imagining these possibilities helps us learn more about the universe and ourselves. Time travel may still be a dream, but it's one that inspires us to keep asking questions, exploring new ideas, and reaching for the stars. We all experience time in our daily lives. It's how we organize our days, from waking up to going to sleep. We think of time as moving forward, never backward. This common-sense view of time is like a river flowing in one direction. For centuries, scientists like Isaac Newton saw time this way too. Time was a constant, ticking away at the same speed for everyone, everywhere. But then came Albert Einstein, who completely changed our understanding of time. Einstein's theory of relativity was revolutionary. One of its most mind-bending ideas is that time is not constant. Instead, time is relative. This means time can speed up or slow down depending on how fast you're moving. Imagine two clocks, one on Earth and one on a spaceship traveling at incredibly high speed. Einstein realized that time on the spaceship would actually pass slightly slower than time on Earth. This effect is called time dilation. Einstein's theories also introduced the concept of space-time, a fabric woven from 3 dimensions of space and one of time. Massive objects like stars and planets warp this fabric, much like a bowling ball on a trampoline. This warping of space-time is what we experience as gravity. But could these warps be so extreme that they create loops in time? A loop in time, called a closed time-like curve, could theoretically allow travel to the past. One of the most mysterious objects in the universe is a black hole. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. Some scientists believe that black holes could be like tunnels through space-time. Perhaps traveling through a black hole could transport you to another part of the universe, or even to a different time. However, surviving such a journey seems highly unlikely with our current understanding of physics. Quantum mechanics, which is, the study of the very small, is a field that has completely transformed our understanding of the universe. Instead of the predictable clockwork world described by classical physics, quantum mechanics reveals a reality that is fundamentally strange and unpredictable. At the tiniest scales, particles can exist in multiple places at once, and their properties aren't set until we observe them. This bizarre behavior challenges everything we thought we knew about how the universe works. When it comes to time travel, quantum mechanics actually adds another layer of complexity. Time in the quantum world isn't just a straight line from past to future. Instead, it can twist, loop, and even branch in ways that seem impossible from our everyday perspective. The rules of the quantum realm allow for scenarios where the past and future can influence each other, blurring the boundaries of cause and effect. One of the most mind-bending phenomena in quantum mechanics is quantum entanglement. This is when two particles become so deeply linked that the state of one instantly affects the state of the other, no matter how far apart they are. Imagine you have two dice, and no matter how far you separate them, even if one is on Earth and the other is on the other side of the galaxy, rolling one die instantly determines the outcome of the other. It's as if these particles can communicate instantly, defying the speed limit set by the speed of light. This spooky action at a distance, as Einstein called it, suggests that information might be able to travel in ways we don't yet fully understand. Some scientists even speculate that entanglement could be a key to unlocking new forms of communication, or even time travel itself. In fact, a few bold physicists have proposed that quantum entanglement could allow information to be sent backward in time. If this were possible, it would mean that messages could be transmitted to the past, potentially changing the course of history. While this idea is still highly speculative and not yet proven, it shows just how strange and exciting the quantum world can be. But the weirdness doesn't stop there. Some interpretations of quantum mechanics suggest that our universe is just one of countless others, a vast multiverse where every possible outcome actually happens. In this view, every time a quantum event occurs, the universe splits, creating parallel worlds where every possibility is played out. There could be universes where dinosaurs never went extinct, or where you made a different choice this morning. So could we ever travel between these parallel universes? While it's still the stuff of science fiction, the idea of jumping from one timeline to another is a tantalizing possibility. If the multiverse is real, then somewhere out there, every version of you is living out a different story. The quantum world invites us to imagine realities far stranger than anything we've ever dreamed, and maybe, just maybe, to find a way to explore them. The idea of time travel is, honestly, full of paradoxes, situations that seem to contradict themselves. One famous example is the grandfather paradox. Imagine you travel back in time and accidentally prevent your grandparents from meeting. This would mean you would never have been born. But if you were never born, you couldn't have traveled back in time to change the past. Paradoxes like this really highlight the mind-boggling complexities of time travel. Even though time travel seems like something straight out of science fiction, scientists actually use math to explore its possibilities. Mathematical equations like the ones in Einstein's theories help us understand the nature of time and space-time. By working with these equations, physicists can model different scenarios and explore potential ways to manipulate time. While building a time machine is still, far beyond our capabilities, the language of math lets us explore the universe in ways we never thought possible. Will we ever be able to travel through time? It's a question that has fascinated humanity for generations, sparking countless stories, movies, and scientific debates. The idea of stepping into a machine and emerging in the distant past or far-off future is both thrilling and mysterious. But is it truly possible, or will it remain forever in the realm of science fiction? Right now, it really seems impossible based on our current technology and understanding of physics. The laws of nature as we know them put up some pretty big roadblocks. For example, Einstein's theory of relativity tells us that as you approach the speed of light, time slows down, but it doesn't let you hop backwards or forwards at will. And then there's the problem of paradoxes, like the famous grandfather paradox, where changing the past could unravel the present, But the pursuit of knowledge is honestly full of surprises. Throughout history, ideas that once seemed impossible, like flying in airplanes or communicating instantly across the globe, have become everyday realities. Scientists are always pushing the boundaries, exploring wild theories like wormholes, quantum entanglement, and the possibility of parallel universes. Each new discovery brings us a little closer to understanding the true nature of time. The study of time travel pushes the boundaries of our imagination and inspires us to keep asking big questions about the universe. What is time really? Is it a river flowing in one direction, or could it be more like a vast landscape we can explore? These questions don't just challenge scientists, they invite all of us to dream bigger and think deeper about our place in the cosmos. Even if we never build a time machine, the journey of exploration and discovery is just as valuable as the destination. Every experiment, every theory, and every wild idea helps us learn more about the universe and ourselves. The search for answers brings people together, sparks creativity, and fuels the next generation of dreamers and inventors. And who knows what amazing things we might find along the way. Maybe the real magic of time travel isn't about machines or portals, but about the endless curiosity that drives us to explore the unknown. The future is full of possibilities, and the adventure is just beginning.